Think of a major city's water supply. It often begins far away, as a wild, high-pressure mountain river racing toward the grid. Electricity works the exact same way. Before it can safely charge your phone, it surges across the country as raw, incredibly high-pressure energy. To bring that wild energy into our local neighborhoods, we need a specialized buffer facility. We need a place to catch and tame the flow. Those fenced-in electrical yards you drive past are exactly that, massive physical pressure management systems for your city. The journey into the city begins at the intake tower. In the electrical world, this is the 33 kilovolt double pole structure, a 30-foot tall gateway. Looking at this specification sheet for the double pole structure, you can see it is built from two parallel steel I-beams. To safely hold back 33,000 volts of pressure, those heavy steel beams have to be deeply anchored into a solid concrete foundation. This tower marks the physical boundary line. It is the exact moment the electricity leaves the wild grid and enters a controlled utility yard. Once the power is inside the yard, operators need a way to turn it off safely, much like shutting off a main water valve before fixing a pipe in your house. For this, they use a massive shutoff switch. Instead of twisting a knob, 3 long metal arms physically swing wide open. This creates a large, visible gap of empty air, completely severing the stream of high-voltage energy. This technical breakdown shows the operating mechanism for that exact switch. You'll notice a long vertical pipe connecting the top blades all the way down to a manual handle at ground level, allowing an operator to safely cut the power from below. But what happens if there is a sudden, unpredictable spike in pressure, like a lightning strike? The system needs an emergency relief valve. We can see this relief valve here in the document, labeled as the lightning arrestor. It looks like a tall, stacked disc structure. If a surge hits, it safely diverts the dangerous excess energy down into the earth. Together, these safety checks ensure that a sudden surge or a maintenance issue won't cause the electrical pipes to burst. Next, the energy flows into the metering cubicle. On this reference sheet, you can see a tall rectangular cabinet with glass viewing windows. Inside, thick copper bars act like heavy-duty pipes, while digital meters count the exact volume of electricity passing through. Even so, the pressure at this stage is still completely unusable for a normal home. To fix that, the energy moves to the superstar of the entire yard, the power transformer. Based on this visual guide, the transformer is a massive, oil-filled steel tank. Because reducing pressure generates a tremendous amount of heat, the sides are lined with vertical radiator fins to keep the whole unit cool. Watch the logic of the flow here. High-pressure energy enters through the tall porcelain towers on top. It shrinks down inside the tank and then safely exits as a much lower pressure flow through the shorter towers. In one step, the transformer takes raw 33,000 volt energy and squeezes it into a steady domestic strength that is perfectly safe to send toward our neighborhoods. Now that the energy is calm, it needs to be routed. This technical sheet details the switchgear panel, a row of vertical cabinets labeled for different outgoing feeders. Think of them as individual distribution valves directing the flow to different parts of the city. Finally, the power dives underground for delivery. Looking at this cable cross-section, the copper core is surrounded by thick insulation and a layer of steel wire armor, keeping the flow completely secure beneath the streets. By the time the power leaves this yard, all the wild, dangerous pressure is gone. It is a carefully measured, highly secure utility. Looking across the entire yard, you can see how it all works together. The intake towers catch the flow, the valves protect it, and the massive tanks step the pressure down. So the next time you walk into a room and flip a light switch, remember what it took to get that power there. You see the light, but the electrical yard does the heavy lifting, taming a river of wild energy to keep your life running safely every